So d by dx of sine to the minus 1 of x equals 1 over the root of 1 minus x squared, multiplied, of course, by the derivative of x, which is 1. So if we want to differentiate sine to the minus 1 of e to the x, so that's how we normally write e to the x. We're going to have 1 over the root of 1 minus e to the x squared multiplied by the derivative of e to the x, which is e to the x. That's e to the x on top. Now, e to the x times e to the x is e to the 2x. If we differentiate tan to the minus 1 of x rather, we get 1 over 1 plus x squared times the derivative of x, which is 1. Now, what we're going to have to do is to work out the derivative of this bracket here, and that's a quotient. So u equals 1 plus sine x, and u dash gives us cos x. V equals 1 minus cos x, and v dash equals sine x. So, d by dx of 1 plus sine x over 1 plus cos x, it's u dash v, remember the formula, u dash v minus uv dash over v squared. So it's u dash, that's cos of x, times 1 minus cos x minus u times v dash, so it's minus sine x times 1 plus sine x, and that's all over v squared. Now we've got cos x minus cos squared x minus sine x minus sine squared x over 1 minus cos x whole squared. So, so it's cos x minus sine x minus, if I take out a negative, that leaves me with sine squared x plus cos squared x over 1 minus cos x squared. So that looks like cos x minus sine x minus 1 over 1 minus cos x squared. So the derivative then is 1 over 1 plus, well, instead of x squared we've got 1 plus sine x over 1 minus cos x times the derivative, and we found that the derivative was cos x minus sine x minus 1 over 1 minus cos x all squared. And we have a square in here as well. Now, the top line of the fraction is going to be cos x minus sine x minus 1. What's going to happen is that this bracket squared will multiply this term, and it will cancel out with the 1 minus cos x squared that's on the bottom. and it will also multiply this term. So what we end up with is 1 minus cos x all squared plus 1 plus sin x all squared. Now, cos x minus sin x plus 1, what we have on the bottom then, we've got to expand these square brackets, so it's 1 minus 2 cos x plus cos squared x plus 1 plus 2 sin x plus sin squared x. And we've got, finally then, cos x minus sin x plus 1 on top. We've got a 1 here, we've got a 1 here, and remember we've got cos squared plus sin squared, so it's going to give us 3. So it's 3 minus 2 cos x plus 2 sin x. So we're going to divide throughout by x, so dy by dx equals 3 over x, I beg your pardon, plus 3 over xy equals 5. Now 5x squared divided by x is 5x. So the integrating factor is e to the integral of 3 over x dx. And that is e to the power of, well, the integral of 3 over x is 3 natural log of x, which equals e natural log of x cubed, and e to the power of log cancels, and that just gives us x cubed. So the integrating factor is x cubed. Now if I multiply throughout by x cubed, I get x cubed dy by dx. X cubed divided by x is x squared, so it's 3x squared y. 5x times x cubed is 5x to the power of 4. Now, I hope you can see, I don't know whether you can see, these two terms then give us d by dx, it would be x cubed y. So if I differentiate the product x cubed y with respect to x, I get this line here. At least the first two terms in that line, and that's 5x to the power of 4. Now, what I want to do is to integrate both sides. If I integrate d by dx, I'll just get x cubed y on the left hand side equals the integral of 5x to the power of 4 dx on the right hand side. That's 5x to the power of 5 over 5, that just gives me x cubed here, y here, equals x to the power of 5, and it's an indefinite integral, so a constant of integration is c. And the conditions were y equals 1, or y of 1 equals 0. Which is to say when x is 1, y equals 0. So x is 1, 1 cubed, y is 0, times 0 equals 1 to the power of 5 is 1 plus c. So 0 equals 1 plus c, and c then equals minus 1. X cubed y equals x to the 5 minus 1. What I can do is divide by x cubed to get y on its own, and y then is x to the 5 divided by x cubed is x squared, and this will just give me then x to the power of minus 3. So dx by d theta is 2, and dy by d theta. Now sine 2 theta is 2 cos 2 theta. So dy by dx is dy by d theta times d theta by dx, which is to say it's dy by d theta times 1 over dx by d theta. So dy by d theta is 2 cos 2 theta times 1 over 2, and that gives us cos 2 theta. Now d2y by dx squared is d by dx of dy by dx, but of course dy by dx consists of the variable theta, so we can modify this then. And we have d by d theta times dy by dx, and then multiplied by d theta by dx. Now, this is the part that I want to do just now. So I want to differentiate with respect to theta dy by dx, and that was cos 2 theta. Now that's not difficult to do, it's just minus 2 sine 2 theta. So d2y by dx squared then is minus 2 sine 2 theta, that's this part here, and we already know that this part is 1 over 2, the 2's cancel, and we're left with minus sine 2 theta. Now, dy by dx, that's cos 2 theta, so dy by dx squared plus d2y by dx squared. Well, we found out that that was minus sine 2 theta, and we want to square that, and that all equals k. So we've got cos squared 2 theta plus sine squared 2 theta. Well, cos squared of something plus sine squared of something equals 1. So k then has the value 1. What I want to do is to find the general term, and that general term is, well, it's going to be 15 r x to the power of 15 minus r minus 3 over x to the power of r. Now, I should really try and simplify this. So we have minus 3 on top, minus 3 to the power of r. Now what we have here, that's an x on the bottom line, that's x to the power of minus. So it's x to the power of 1 where it is just now, but when it comes up onto the top line it's x to the power of minus 1, and it's x to the power of minus 1 all to the power of r, so it's x to the power of minus r. We've got 15, choose r, and that's x to the power of 15 minus 2r times minus 3 to the power of r. Now this is the part that we want. We're interested in x to the power of 7 So x to the power of 15 minus 2r equals x to the power of 7. Means that 15 minus 2r equals 7. 15 take away 8 is 7, so 2r equals 8 and r equals 4. So if we pop 4 back in, we have 15 choose 4. We know that this will give us x to the power of 7. Let's not forget the minus 3 to the power of 4. And some calculator work then. So that's 1365 times 81 x to the power of 7, and it gives us 110,565 x to the power of 7. Partial fractions, so 4x squared minus 4 over x squared, x minus 2 equals a over x. Now this is a repeated linear factor, so we have b over x squared plus c over x minus 2. And when we combine everything over the common denominator, which is x squared, x minus 2, what do I multiply this x by? To get the common denominator, I multiply by x, x minus 2. What do I multiply this by? To get the common denominator, I multiply by x minus 2. So what do I multiply this by? To get the common denominator, I multiply by x squared. So we can compare the work with the top lines, the numerators. Now we need to choose values of x, which will make our working easier. First value of x I'm going to choose is x equals 0. Left hand side gives us minus 4. First term and the last term disappear, so that's minus 2b. That means that the b then has the value 2. I'm then going to choose the value x equals 2. 2 squared is 4 times 4 is 16. 16 take away 4 is 12. The left hand side gives us 12. The first and second terms on the right hand side disappear, and we're on to the third term, so 2 squared is 4. 4 times c. C then equals 3. And the last thing I'm going to do is to choose the value x equals 1. So the right to the left hand side gives us 0, which is useful. Minus a, and minus b, and plus c. Now we already know the values of a, b and c. So what we have then is 0, we want to work out the value of a. So if I take a onto the left hand side, a equals minus b, which is minus 2, plus c. So I want to express in partial fractions then. So it was a over x, a is 1, b over x squared, b is the value 2, and c over x minus 2, c is the value 3. The auxiliary equation is m squared plus m minus 2 equals 0, which can be factorised to give m and then we have the values m equals 1 and n equals minus 2. We have the complementary function then, y equals a e to the 1x plus be to the minus 2x. The next thing we want to do is to consider this here. So the form of the particular solution is going to be, let's try y equals c e to the 2x. Now we know that y dash then will be 2c e to the 2x, and y double dash will be 4c e to the 2x. Now what we're going to do is to substitute these values y dash and y double dash into this left hand side. So d2y by dx squared, that gives 4c e to the 2x, plus dy by dx y dash, that's 2c e to the 2x, minus 2 lots of y, 2 lots of c e to the 2x, and that equals 4 e to the 2x. 4 lots of c e to the 2x equals 4e to the 2x, and c then has the value 1. So the general solution of this second order differential equation is y equals ae to the x plus be to the 2x plus c, which is 1, e to the 2x.